Welcome. I will be dealing with set theorem. Set can be defined as a collection of well-defined objects. Now, if you have a math set, it's a kind of set, an example of a set, because inside the set, inside the math set, we have different components. The pair of compasses, the ruler, the protractor, and all the rest. They are a well-defined object inside. Now, if I have a value set A to be 1, 2, 3, and so on to 10. This is a set, example of a set. And inside the set we have 1 to 10. These are elements of the set. So the member of the set are often called elements of a set. Now, there are different kinds of sets. The finite set, the infinite set. Now, this is an example of a finite set. This is an example of a finite set because it stops at the point 10. But if I have a B and it's 1, 2, 3, 2, and so on without a stop, then it's called an infinite set. It's an infinite set. A finite set, a finite set, an infinite set. So when we talk about set, it can come in various ways. Supposing I have a value A and I wish to rewrite this, I can say S such that 1 is less or equals to X less or equals to 10. This is another way to write this. That is, S is such that 1 is less or equal to S is less or equal to 10. That means that it's an example, just another way of writing this. If I wish to have B, supposing I have a B and another one apart from this, and I have S such that 1 is less than S is less than equals to 5. The interpretation here is that I have 2, 3, 4, and 5. This is the interpretation of this one. It's different from this. I can say this one is my C. I can say this is my C because it's different from the completely. So this is the interpretation of this value. I wish this is clear. I wish next time we're going to be doing more of set theory. Thank you.